Hey 8th graders, today's lesson is 1.3 Force and Motion, and our learning target for today, I can demonstrate how a force can change the direction of an object. So in our last lesson, 1.2, we learned about the 5 different ways we can change the motion of an object. If an object is already moving, we can stop it, okay, we can speed it up, we can slow it down, or we can make it change direction. If an object is stopped and not moving, we obviously can change its motion by getting it moving to begin with. So what we're going to look on is how forces accomplish those changes in motions for us. Okay? All right, moving on to slide 2. This is your activity 1 notebook. So you guys have a couple vocab words and a couple key concepts to add into your OneNote today. So go ahead, open up your OneNote, add force and exert to your vocab page, and then add key concept number 1 into your key concepts page. So if I pull up my OneNote here, in my vocab, you guys should see force and exert. So here is force is a push or pull that can change the motion of an object. So an object doesn't have force. A force is something that happens to an object. So I really want to distinguish between that. Again, an object does not have force. It experiences a force. So we can exert a force onto an object, but it does not have a force. So with that being said, exert is our next vocab word, is to apply a force. Okay, and then your 2 key concepts for today. Key concept number 1, a force is required to change the velocity of an object. And key concept number 2, how an object changes velocity depends on the direction of the force exerted in that object. So we're not only going to talk about how a force can change an object's motion today, but we're going to talk specifically about how different direction forces that are exerted on an object can change their motion in different ways. So we're going to get a little bit more specific on directions that we're exerting those forces. Just as kind of a reminder too, we talked about velocity being speed in a certain direction. This is where that difference between speed is coming from. Okay, speed is just the time traveled, or excuse me, the distance traveled in a certain amount of time, whereas velocity is the distance traveled in a certain amount of time in a specific direction. So again, when we're talking force, it's important to know what our motion of our object or our velocity of our object based on the direction as well is also moving. So when we apply a force, we know specifically what happens to the direction and the velocity change. All right, moving back to our assignment for today. Your guys' warm-ups were on slide 3 and 4. So which image shows the directions someone would need to kick the ball in order to make it move toward the goal? So you can see here is the little ball, here is the goal, okay? And you guys can show either the ball being kicked this way or the ball being kicked this way. So again, how would you guys score the goal? You guys are going to use your draw tool to circle either A or B. And then you're going to click down here and explain why you chose that image. So why did you choose either A or B? Okay, so those arrows represents the force you're putting on the ball, so you might want to try to use that in your warm-up today. Okay, then which image shows the faster moving ball? Again, this is the ball, here's the goal. Both of those balls are moving toward the goal, so which one suggests that one is moving faster? Again, you'll use either your draw tool to either circle C or D, and then you'll click to type down here to explain why you chose either C or D. Okay? Remember that at any point you guys can pause this video, complete a section after I describe it, and then come back to this video. So I'll go ahead and give you a second to pause. Then you guys can come back in and we'll talk about our next activity, which is the simulation. All right. Moving on to activity 3 on slide 5. Here's your simulation. You guys will go ahead and click on that link. You guys will right click it, open it up, and it'll bring you into the sim, which looks a little something like this. This should look a little familiar with you. We had one assignment we did back in our Harnessing Human Energy towards the end of that unit where we used this exact same simulation. So I want you guys to just pause this video for about 5 minutes and go and explore and figure out all you can do in this lab. There's a lot of different things that you guys can accomplish with this. So go ahead and take 5 minutes to explore, and when you guys are done exploring, go ahead and come back to this video. All right, so you guys should have explored. Obviously, you can see that when we click, we can change velocities of objects to get them moving before we exert a force, or you guys can exert a force after. If you guys click run, you guys are able to add a force to an object in many different ways. So the more you click, the more you can change the force. You guys also can click on an object in the build and exert a force from there. Okay, So there's a lot of different things you guys can do with this. You can change the friction of it. You can look at the different forces in Analyze. So I'll go ahead and, if you guys haven't figured those things out again, you should have taken a couple minutes to explore. If you really didn't do that, make sure you guys do that. Okay? All right, moving on to the next part of the simulation. So for on this one, you're going to use the force and motion simulation to discover what you need to do to change an object's velocity. So in class today, I paired you guys up in groups of 4, and you guys each took a chance to explore one of these. I'm going to do the first one for you guys. And then you guys are able to share these with a partner. Since you guys are working by yourself from home, you guys will need to complete the other 4 of these on your own and figure out how you can accomplish these tasks. So these are the different changes in motion or velocity that we saw from the last lesson 1.2. Again, an object can either start moving, it can speed up, it can slow down, it can stop moving, or it can change its direction. Okay, you guys are going to figure out how to demonstrate this in the simulation. So how you made this change. So I'm going to do start moving for you guys. Okay, so I'm going to open up my sim here. Okay, and then I'm going to go ahead and for the first one I'm doing start moving. So obviously this suggests that I'm going to start out with a horizontal velocity of 0. Okay, then I'm going to go ahead and hit run. And for this, I'm going to go up to the upper right hand corner and I'm going to choose prepare force. Okay, once I prepare my force, okay, I can do this in any direction. I can click it any amount of times. Obviously, the more I click the force, okay, the larger that force gets, or the larger the pink arrow, which represents the force, gets. Okay, so I can do forces up, down, left, right. I can even do them at an angle. Okay, so once I've prepared my force, I can go ahead and hit play, exert my force. And then you guys can see that that object, which was stopped, is now moving, okay? If I go into Analyze, I can check out, I can replay everything that happened. And I can also check out the final velocities of these of this puck at any point in time. So if I look at this, I had 6.5 kilojoules of kinetic energy. I started with a velocity of 0. My current velocity at the end of that, you guys can see the change horizontal and vertical. There isn't any diagonal. So if I wanted to do this more simple, I could just put on there, all right, let's go run, exert force or prepare force. I'm going to go ahead and click 3 to the right and then exert that force, okay? So to start moving, to make this simple, I can say I hit prepare force. 3 clicks to the right, exert, okay? So I kind of give little directions on how to do this, okay? So you guys will do the same thing, except you guys will figure out how to get an object to speed up. So if we're having an object speed up, it's already moving to begin with. So when you guys start this build, you guys are gonna want to start your thing off already moving. So if you guys click on that, we're going to go ahead and add a horizontal velocity of 1 centimeter per second. Our goal is to apply a force to make it move faster than that. So if I go ahead and hit run, okay, I'm going to go ahead and pause it and prepare a force. And I want it to speed up, so I'm going to add the force in the same direction. And that's going to be important for you guys to take note of. So I'm going to go ahead and add 1 click. It was moving to the right, so I also want my force to be to the right. And then I can hit exert force, okay? When I analyze this, at the end you guys see that my current velocity, horizontal velocity, is now 2 centimeters per second, okay? So I started at 1 centimeter per second, then I exerted a force, and now I'm going 2 centimeters per second. So for this one, I would prepare my, I would have my puck move to the right, horizontal velocity of 1 centimeter per second. Okay, I prepare my force, and then I would add force in same direction, and then I would exert. Okay, so you guys definitely want to include the direction that you guys are adding your force, because that's going to make it different. If you guys do your force in the opposite direction, or you don't specify which way your force is, you could either be stopping or slowing down your object. Okay, so it's really important that you guys kind of give those good details in there as to what specifically you did to make this change. Okay, so you guys are going to go ahead and take a second, figure out how to slow down, how to stop an object from moving, and how to change its direction. Okay, make sure again that you talk about the direction that you're exerting those forces, because that really does make a difference. Okay, moving on to the next part of the sim, you're going to gather more evidence about velocity. Okay, so we're going to talk a little bit more about that direction piece of applying a force. So what happens if we apply different directions of forces? So use the force and motion simulation to determine how to exert a force to cause an object's velocity to change in each of the 5 ways. So again, we're looking at those same 5 ways we just looked at. Predict the direction a force must be exerted and use one of these options. So before you guys begin your simulation, you're going to do predictions. So let's take a look at the next slide. Okay, in order to get an object to start moving, okay, which force do you think you'll need to do? So again, you're doing this all before you even open the sim. So you're going to predict whether you're going to use a force in the same direction as its motion, in the opposite direction of its motion, or in any direction of its motion. Okay, so again, same direction, opposite direction, or any direction. So you guys would type one of those 3 options in all these part of this whole column of your guys' table right here to predict how you guys would make these change of motions of the puck. So to get something to start moving, we kind of note that it's already stopped. So there isn't a direction of the motion as well. So that kind of rules out our first 2 there. Because it's already stopped, it's not already moving in a motion, it's not moving in any particular direction. So for this one, we can use any direction for that. So I would click in here and type any direction. Okay, so that would be my prediction, and then I would go and test that. So I go back to my build. Okay, can I get this to start moving by applying a force in any direction? So I can go ahead and run it, prepare my force. I can try going up and see if that gets it moving. Sure enough, it does. I can go to rebuild. I can try doing a force to the left, prepare my force. I'm going to go to the left, exert my force. I can get it to move from that too. So I can kind of see just from those 2 examples that I can get it to move in any direction by exerting a force. So on this one, my actual answer was any direction. And you very well may be able to predict all of these correctly. Whoops. Okay. All right, moving on. How do you get an object to speed up? Would you guys, so make your prediction first. Would you apply a force in the same direction as its motion, in the opposite direction as its motion, or any direction? Okay, so which one do you think? And then go ahead and test it out. Okay, get it to slow down. Again, any direction, opposite direction, or same direction. Stop moving, any direction, same direction, or opposite direction, and then move in the opposite direction. How do you guys think you would apply that force? So go ahead and make your predictions for these remaining 4, and then go ahead and test them out in the sim to see if you are right. Okay, if you are wrong, make sure you guys do the actual answer in this last column. Okay? Finally, let's revisit our pod here. So we knew that we had those missing seconds in the video where the pod just kind of moved in the other direction. We don't really know what happened, but we had the 2 claims. And the first claim was that those thrusters fired a little bit too much, and that turned the pod around and started moving it away from the space station. We also had the theory that the thrusters didn't quite fire enough, and it didn't slow down the pod. It hit the space station, and the pod bounced off and moved in the opposite direction. So we're really kind of studying those 2 options right now. So thruster force for ACM pods. We know we had the pod approaching the space station at a medium speed. The thrusters fire to stop the pod, and then the pod docks with the space station. So refer to the series of images for asteroid collection missions, which I just went over with you guys, and then complete the sentence that indicates the direction of the force required to stop the pod. So from this, the thrusters fire to exert a force in the, you guys will either circle same direction or opposite direction as the motion of the pod, and that causes it to stop. So basically, those thrusters, are they going opposite of the motion of the pod or with the motion of the pod in order to get that pod to stop and dock with the space station? All right, moving on to your last activity. You guys have this little sorting tool, so you guys will need to right-click and open this sorting tool up. Okay, it looks a little bit something like this. This is a little practice on cause and effect. So you guys have all of these little images over here, as well as these little effect cards that you'll need to sort into these 2 cause columns. Okay, so let's go ahead and read these instructions first. Open the force and motion sorting tool activity, cause and effect, which we already have open. When your model is complete, press hand in. In the substitute for this, we're obviously going to screenshot that and insert our screenshot on the next slide. Your goal is to identify the direction of the force that will cause each change in velocity. So drag each card to the appropriate column. Okay, so let's take a look at this again. We have two columns. Okay, they're both causes. Okay, and you guys are going to kind of be looking at the effect of these causes. So cause number one, an object is pushed in the same direction as its motion. So we're going to be looking at the effect of that. What effect is that going to have if we apply a force in the same direction as an object's motion? Okay, and then cause number two, an object pushed in the opposite direction as its motion. So if we exert a force in the opposite direction that an object is moving, what's going to be the effect of that? So let's first take a look at these little effect cards. Okay, so we have object reverses direction. You guys would click that and drag that to the cause that it belongs with. So if an object is moving in an opposite direction or it reverses its direction, that means that the force must be applied opposite to the direction of its motion. So I would drag that over here. So again, if I have an object moving this way, I would have to get a force, I would have to apply a force in the opposite direction to get it to turn around and move. Okay, so effect, object reverses direction. So that one would go over here in the second column. Okay, you guys can go through the rest of your effect cards and figure out which column they go into. And then up here I have these little pictures that I also need to sort out. So if I take a look at, let's do this one right here, the second one. So before my push, you guys can see it's moving, the little blue arrows behind it kind of suggest it's moving at a slow or a low velocity. And then obviously I have my cause, either an object pushed in the same direction as its motion or an object pushed in the opposite direction. Okay, one of those is going to make my object speed up. Okay, and then your correct answer should be this first one here. So your cause is that an object is pushed in the same direction. So we have it moving to the right. So obviously we need to apply a force to the right to get it to speed up. So I would drag this one over here. Okay, you guys will finish sorting these other 1, 2, 3, 4, 5 little picture cards and then the last 3 effect cards into either one of these columns. So again, object is pushed in the same direction as its motion or object is pushed in the opposite direction of its motion. Okay, once you guys are done with that, you guys will go ahead and screenshot. Remember, if you're using a Chromebook, you guys hit Control Shift and then the little key above the 6. You guys will hit capture and then you guys will Control V, paste it right here. Okay, if you guys are using something other than a Chromebook, maybe just a laptop, you guys can use the snipping tool, click New, click and drag to highlight what you guys would like to snip, which should just be this little area of your sorting tool. And then you guys will go ahead, Control C, copy, and Control V, paste it right here. Okay, once you guys are done, go ahead and do your wrap up. Do you have any questions? Circle yes or no. If you guys have any questions, type them here. You don't have to fill that in if you don't have any questions though. And then 4, 3, 2, 1, how do you think you did on this assignment? Okay, once you guys are done with that, you guys can go ahead and hand this in and I will talk to you soon. Thanks, bye.